Right, great. Great to be here. Are you all enjoying the event so far? I am enjoying the event, so let's get right into it. Okay, so first I want to present you 4 websites for web applications. You probably all know them. So we have Allegro, the big shopping site, shopping platform. We have some kind of mobile web application for a web bank. We have a music player, you know it probably, and we have an online retailer. So what do all these applications have in common? I think you will think it has to be something about the architecture, right? Because my talk will be about architecture. So maybe they're using same architecture, but when we write software, we never think about architecture first, right? The architecture is always a product of something. It is an outcome. It is driven by some requirements, by some quality attributes. So what drives? The first question is, what drives all of these architectures? And when we write software nowadays, it is mostly done by distributed teams that are responsible for the parts of the system they write. I work at Bayer Digital Hub, and Bayer is a global company, so we have teams in my area which are distributed between the United States, Europe, Asia, and South America. Next thing, iterative development. So probably most of software developers, most of you work in some agile methodology, Scrum, Kanban, whatever it is. But we don't think about monoliths or about waterfall development right now, when it would take a few months just to develop the software, then a few weeks to integrate all the modules together, and then on a weekend or at some time where no user would use our application, during some maintenance window, we would all deploy it and then pray so that everything works together. No, we want to do quick deployments, fast, frequent deployments, and big companies, like for example LinkedIn or Facebook, deploy hundreds of times a day, deploy to production, and they are not afraid of doing it. At Bayer, we also do fast deployments to production. And what is very much linked with those fast deployments is what I love a lot, is that experiment-friendly culture. So when you write software, when you write web applications, you no longer rely on a thought or a feeling. So I feel this UI, there is a pointer here. This UI is better than this UI. This UI will allow us to sell more. No, we will deploy both UIs to, user A, like myself, user Paweł, will get this website with this view, and user Alice will get a different style of the button, and we will carefully measure what is closer to our business targets. So what is the click rate? What is the conversion rate? If it was a shopping website, what is the average price of items in the basket for a user using this versus this? And we can clearly see this is better. Okay, so we roll it to all of our users, right? So a certain architectural style will support this kind of experimentation and measurement to make our application better and bringing more business value. So let's start with a definition. I will talk about micro frontends, and this is an architectural style. So what I love is software architecture. So this is one style of building front-end applications that are independently deliverable. Okay, so this independence, it will manifest itself during the rest of the talk. And they are composed into a greater whole. This is a very simple definition. I like short and simple definitions. It is by Cam Jackson, Martin Fowler. You probably know Martin Fowler, the guy between the design patterns. And it just gives the essence of what we'll talk about. So my name is Paweł Kozioł. I'm a software developer at the Bayer Digital Hub here in Warsaw. We started 2 years ago. We want to employ more than 400 software developers, data scientists, architects, IT people. We have more than 200 so far. And Bayer is a life sciences company. So what I like a lot, it's that it comes with a purpose. So I have a feeling that I'm doing something meaningful. I work in the crop science, that is agricultural part of Bayer, because we specialize in agriculture and pharma, medical sciences. And what I want to underline is that we rely heavily on software. So when you think about agriculture, it is not anymore a farmer taking a shovel and digging a hole in the ground and putting some plant there, watering it and watching it grow. No, it's all supported by machines and by a lot of software. And I think many of you might have been to the previous presentation by the colleague from the military area, and you saw tanks, you saw airplanes, and you saw all those pictures with those command centers, all powered by hardware and software. So we don't have any tanks in my area, but we have tractors, we have specialized other specialized vehicles. I don't even know the names, so I won't pretend I know them all. But we also have drones, we have satellites flying over our fields, we have aeroplanes, which are in the US. It's very common that an aeroplane will fly over the field and just spray the plants with whatever protection they need. And it's the same in medicine. We process a lot of data to produce new drugs. We write software that runs all those robots that combine different medical compounds and measure their reactions with some proteins that we care about. And in 10 years of such experiments, gathering a lot of data, and it's heavily supported by machine learning and AI as well, we will produce a new drug. So in my area, a sample project would be in the case that we would have a drone or other some kind of machine flying or riding through the field and taking pictures. So this is a corn field, and the farmer grows corn there. And the idea is that from those pictures of those corn ears, this is a corn ear in English, we want to count how many seeds, so corn kernels, we have in such an ear. And this is quite a complex task, because we have those ears being at different angles, from different sides. Always on a picture we see just one side of it, but we need to count. So the AI somehow needs to be trained and count. So how much yield, how much of that corn can the farmer produce out of their field? And how all the treatment and everything that we do to those plants, how it benefits a better yield. So this is just one sample project. In crop science, in the agricultural field, we have more than 8,000 software projects. And we write a lot of software, a lot of web applications. So coming back to the presentation topic, we write that software, and that software is driven by all those cases. So I've already said we have those distributed teams, and each team is responsible for one of the fragments of the code. Here maybe a short case of the distribution, how we divide the software into those fragments. So when anybody asks you what should be the scope of a micro frontend or what should be the scope of a microservice, then the answer I like to give is think about domain-driven design. So think about teams. Each team is responsible for one single domain or subdomain, and this is the this gives the boundary to one of the fragments, whether it's a micro frontend or a microservice. We will see a lot of examples about that. Focusing on the micro frontends, now I'd like to look at this architectural style from different angles. So we will cover the definition again from slightly a different angle than the composition, how the web page is composed out of those fragments, the micro web apps, micro frontends, fragments. It's all about the same thing. Then routing and navigation, because it is at the core of web applications, so that the pages are linked with each other, and how the micro frontends can communicate with each other. Okay, so first, the definition, how we can think of a web page is the vertical split. So we may observe that some web applications have that central view which is specific to a single domain. And here I like to give the example of some banking application which has different domains for the customer, like you can have the payments, the accounts view, the savings or investments. And you can build the application that one team, one software fragment is responsible for just handling one separate view, which is quite independent from others. And you will also have some kind of navigation, whether it's on the side or on the top. And what is interesting that the navigation fragment can be a micro frontend of its own. And here you just you have those pages some kind of linked to each other. When you click on accounts, you load the appropriate view and so on. So this is what I will call the vertical split. And next comes the horizontal split. So we may think of a music player, like the one I showed at the beginning. And here, the user will mostly interact with a single web page at a time. So the view doesn't change that much, but you have all the domains kind of composed together and embedded into that single web page. So on the left, you can have the artist list. Then when you click on it, the web page is very interactive, right? So you will see your recently played songs, and you will see some suggestions. And when you select an artist, you will see the module, some kind of web module to play a specific song by that artist. So we already see that those micro frontends needs to be connected to each other. They need to exchange some information. And what's also interesting is that you can have a single icon like add to favorites, or it can be the like button on a Facebook site, or it can be the shopping cart. You can have a single icon where all the logic behind that is implemented by a specific micro frontend. So this is, for me, this is fascinating how granular you can get in that design. Okay, so that would be about the definition. And what's very much linked to that topic is the composition. So we've already seen how the website is composed out of those micro fragments, micro frontends. And you can have different composition patterns. So the simplest one would be separate pages. So it could be even simpler than this one, where all the pages will be totally independent of each other, so they could share some navigation or even not have any navigation. So using links, you would navigate to different pages. So this would be like a kind of federation of separate web applications. And we could call each web application a micro frontend. Well, not very composable, but anyway, it is a valid pattern. Then we could use iframes. And who of you thinks iframes are kind of outdated? It's old school technology. Yeah, I can see some of you. I used to think that as well. So iframes are definitely an old technology. They have their drawbacks, like if you embed an iframe into your web page, it's not very resizable. It has many bad sides about it. But they are a perfectly valid technology. They are there for a purpose. So if you want to have strong isolation, if you want to embed some third-party application into your web page, like for example, credit card payments, where you also need some security. You don't want information to leak from one micro frontend to the whole site or to other micro frontend. You don't want the styles, the CSS styles, to leak from one micro frontend to the other. Then iframes are a perfectly valid technology. You just have to know how to use it and why you are using it. And I want to say that, for example, the Spotify web player that we've seen, it uses iframes. It used to use iframes a lot to compose the web page. They have slightly changed their implementation now, but it still uses iframes. So it is a valid technology used by many modern sites. Then you have you can have some client-side composition. You can use web components. It's a great web standard, or other implementation of components to build the site. And if you have some special requirements that we'll talk about later, it is very common to use server-side composition. So you can have technologies like server-side includes, or you can use frameworks like Tailor by Zalando or Podium, or Allegro uses their own framework. So there are very many server-side composition technologies that essentially speed up very much loading of the page, and they have a very good effect on the search engine optimization metrics because, well, it's very fast. I will name some more advantages of the server-side composition later. And actually in both client-side and server-side composition, you can also implement lazy loading of your fragments with AJAX calls. Then the routing and navigation. So as I said already, we can have those separate pages, just use standard anchors, links, navigate from one page to another. You can use the client-side routing, and oftentimes you will use the application shell. So this is a special implementation pattern I will cover in the next slide because it's very interesting, and actually most of the pages I have implemented using micro frontends use that application shell. It's very common. And then you can rely on the server to do the routing. So you will implement some backend proxy, like for example using Nginx, that will cover the routing for you. Sorry. So what is that application shell for the client-side composition and navigation? So actually, that application shell is a very thin kind of layer, a small framework, and this is on the given on the example of single SPA, which is I would say the reference implementation, a very common implementation, and actually that layer of that shell that you will use is actually mostly very simple. In most cases, it's very, very simple. It doesn't have to have much logic in it. It is responsible basically for registering some child applications, some child components. So those micro frontends, those micro fragments that we want to use on our site. It basically has some kind of notion to register them and then handles the lifecycle methods of those microfragments. So it can handle the bootstrapping, mounting, displaying, unmounting. So basically, handling the display or navigating to another fragment, basing on the user's navigation. And it can implement other functions as well, like for example communication, some kind of communication facilities that I'll talk about in the next slide. So when you have your root application, meaning your index.html file, the first file you will load from the server just to start your application, it will just contain a small script to load that shell, and then that shell will be present in memory for the whole time you interact with that web page, and that shell, here being the single SPA, will manage all those microfragments. So this is client-side composition with the application shell. And then, as I already explained on the example of that music player, well, oftentimes we need those micro frontends to exchange information. And for that, we have a few technologies, a few patterns. So you can do it via the browser-provided techniques. You can store some data in the URL, not too much, but you can use some attributes in the URL to store data. You can use local storage. Well, that's very common to use that. But what I like a lot would be those custom events. So maybe you know there is that web technology of custom events where you can define your own events, and then you can define the handlers for those events, asynchronous handlers that trigger when that specific kind of event is emitted. So this is great for that message-driven, event-driven interaction of your microfragments. You can also have your own event bus. So basically, also basing on that concept of those events, and you can implement this event bus. You can provide your own implementation in that application shell that I've mentioned. So apart from handling the lifecycle methods of those microfragments, the application shell can also provide some means of communication. And of course, you can use the backend calls. So each micro frontend can communicate with its own backend, with whether it is some kind of gateway for all the microservices you have, or whatever you have in the backend, or it can each talk with its own microservice, and then they can be connected with, again, with some gateway or message bus, and they can exchange information and provide information to that other micro frontend. Okay, so we've looked at those micro frontends from the perspective of definition, so the vertical and horizontal definition, the composition, routing and navigation, communication. And now let's look from slightly different angle. Let's look at some kind of a decision framework that can allow us to reason what kind of implementation we want to choose and why we want to choose it. So here I will also refer to those concepts introduced before, but again, it's a look from slightly different angle. And this diagram bases on a very good book that I highly recommend, Microfrontends in Action by Manning, published a few years ago. It gives a great introduction to the microfrontends and allows to analyze those implementations from different angles, which is great to understand. And it provides a lot of examples as well. So here, in that decision framework, the first question we would ask is whether we require strong isolation. So I've already talked about isolating a certain fragment so that it doesn't exchange information, doesn't interact. It cannot interact with the other fragments we have on the page, like for that credit card payment or verification example, or I don't know, some other payment technique. And here we can use linked pages, so that provides obviously the greatest level of isolation you can get, because, well, one page cannot interact with another page. And if you need to compose several microfrontends on the same site, you can use iframes for that. If you don't require such a strong isolation, then it gets more interesting, because we can use some other more advanced techniques. So here the next question I propose that we can ask is, do we need fast page load, first page load, or that progressive enhancements? So this is very important, as I already kind of suggested, for all the retail sites. So I would say most or all of the companies in the retail area, like Amazon or Zalando here or Allegro, would use some kind of server-side rendering. So we can see if the answer is yes here, you most likely land in the server-side enhancement, server-side rendering or pre-rendering zone. Why? Because it is very fast. So everything you can do on the server and well, in the cloud, or you can also use the edge locations for that. So not only the closest, if you use, for example, Amazon or any other, well, it doesn't matter what cloud provider you would use. But on the example of Amazon, you have those regions that are composed of availability zones, right? So you have a few availability zones in every region, and you always try to deploy your application in the region that is closest to your users, right? Because of the light speed. Well, light is very fast, current is very fast, but like going from here to Australia or from here to the US will give us a lot of latency. So we want to have the application deployed in the nearest possible region. But even even for the region, we have some kind of a few milliseconds of latency if like from Warsaw we use Frankfurt. So we have those edge locations, and Amazon and other providers already have their edge locations in Warsaw here. So imagine what kind of a latency bonus you get if your parts of your applications are deployed here in Warsaw and for the Polish users, right? So, what I'm heading at is that when you offload some parts of the rendering to the server, some kind of pre-rendering, pre-generating of the HTML, and then sending the ready HTML to the client, it's much faster than doing that on the client side. And this also gives you the benefit that you minimize the layout shift. So you can already pre-render the application. You have the whole structure of the application in the HTML. You send that to the client, to their browser, and you don't have that annoying layout shift. So, for example, when an image pops up and suddenly the content below that image goes down. Okay, and this is a metric that is very crucial for Lighthouse, for Google, for search engine optimization. So, if you want your website to rank highly in Google search and have good Lighthouse scores, you will also care about that. And with server-side rendering, most websites can achieve speeds like 1 second or below 1 second for the whole page to load, which is quite good and quite impressive, and I would say a standard for web pages. Okay, and here, whether you choose yes or no, the next question we ask ourselves is, do we want soft navigation? So soft navigation is like seamless navigation. When you click on a link or any button or any fragment, you do not want the whole page to reload. You just want instantly the next view to be available. And for that, you would use that unified single page applications, where unified means using that kind of application shell. So the application shell gives you the impression that you're always interacting with the same single web application, that it's not few linked applications. Okay, so basically here the distinction is whether you would use that application shell or not, and for the fast first page load, the distinction is that you would additionally use server-side rendering. And that universal term here, what does mean universal? It means universal JavaScript is a term for JavaScript that is executable both on the server side and on the client side. So it's the same, it can be the same JavaScript, but it can be partially executed on the server side to pre-render fragments of your page. And when we talk about micro frontends, micro fragments, I want to talk about one specific case, one specific pattern I like very much. Who has heard of that strangle fig, that plant or that web pattern here? I mean, architectural pattern. Martin Fowler. You haven't. That's great. Maybe I can show you something new. It's very simple, actually. So we have a fig tree or any tree, and those twigs here growing down is a parasite. So this is that strangler fig plant that grows on a tree, and it produces more and more of those twigs, and eventually it just kills the tree because there are so many of those twigs that they suck all the energy and all the living forces from the tree, and the tree dies. And this is a great thing you can apply. So Martin Fowler has applied that plant analogy to refactoring applications. So imagine you have a whole legacy application. So all of this is implemented by a monolith. There is no separation into micro frontends. You have a big monolith that you deploy all at once, and you want to rewrite it. So how could you approach it? Well, one approach is to extract those views one by one. So instead of a legacy view, you prepare a payments, which is a new view. So you extract that micro frontend on the front-end side. You can do the same thing on the back-end side. I won't say it's easy, but you can do it screen by screen, and eventually all your new screens, your new fragments will kill that monolith because there will be no more of the old legacy screens. And you can apply the same pattern to other composition, to that horizontal composition as well. Right, so I have used this. That's why I'm sharing it. I have used this for a few applications that I was rewriting. So not every time you start with a greenfield project where you can have multiple teams and you choose that domain-based composition of your application. You define the subdomains cleanly and perfectly, and you assign different teams to different domains. No, you oftentimes start with a legacy. So this is one pattern that can help you deal with that. And I would like to end with another diagram. So I hope with those diagrams I can show you that you can look at the architecture, look at your patterns from different angles and analyze what fits best your project. So always think about those drivers and choose your architecture deliberately. Think of it and make it a conscious choice that applies to your requirements. So here you can also analyze what is the simplest, what is the most complex. I won't go into detail because we're already running out of time, but you can think of a spectrum like links and pages or linked single page applications will be the simpler solutions. And then you can have those linked universals. So universal meaning running both on backend and frontend for that server-side composition. And if you use, like, combine both, so you use server-side rendering and application shell, which you can both combine, that would be a very complex, but some companies use it for all the benefits you can get from that combination. Okay, I hope you bear with me for that very short, very fast run through the micro frontends topics. Thank you very much. Well, micro frontends are fascinating. Software architecture is fascinating. So I hope you can read more about it. I hope I kind of whet your appetite for that topic. And for any questions, I will be here probably in the corner or outside, so you can reach me or other colleagues with that buyer blouse, and we'll be happy to answer all questions. Thank you very much.